in calculus, you run into a lot of theorems. Okay, a lot of theorems when it comes review time in April that you need to be familiar with. Okay, each theorem has its own set of conditions, its own set of rules, so to speak. So there's a lot to learn with these theorems. I feel like this is our first big theorem. I don't think we've had any others. Okay, but this is our intermediate value theorem. Okay. Continuity of a function will prove to be an important characteristic in many theorems for our course. In order for theorems to be properly applied, we need to meet the certain conditions. Namely, the if part, called the hypothesis, must be satisfied before we can apply the then part, or the conclusion. Okay? In this lesson, we explore our first existence theorem. Existence theorems allow us to draw conclusions about a function's behavior on an interval without precisely locating that behavior. So, in other words, when we talk about an existence theorem, we're just going to be able to say, okay, because this and this condition exist, or because these conditions are true, this situation exists. I don't know where it happens, but I know that at some point between A and B, this has to be true. That's an existence theorem. Okay? Now, we're talking about the intermediate value theorem. Okay, note, IVT. Very, very common abbreviation for intermediate value theorem. To the point, if you are trying to rationalize something on a free response AP problem, you can say IVT and any grader is going to know exactly what you mean. Okay? So, intermediate value theorem, IVT. The IVT says that a continuous function on an interval cannot skip values. So, in other words, if we know a function is continuous from point A to point B, that it cannot skip values. Does that sound logical?
So it can't be like a jump discontinuity?
Right. But we just gave the word continuous, right?
Meaning it can't be discontinuous.
Right. In other words, if something is continuous, that means that there are no discontinuities, right?
Yeah.
If there are no discontinuities and it is continuous, that means we cannot skip values. So that means every single value from point A to point B is going to have, there's going to be an existing point there, or an existing value. Am I making sense there? I mean, basically it just says, okay, here's point A, here's point B. I don't know what the graph does here, but it's going to exist every place. Okay.
Oh, so it doesn't mean like the entire graph, it just means like the entire x-axis? What?
Yeah, from here to here, the graph is going to exist for all x values.
Oh, okay.
Yeah, no, not necessarily y values, because y value is going on infinitely. So, okay. So, if a function y equals f of x is continuous on a closed interval means my endpoints are included, and f of a does not equal f of b, then f of x takes on every value between f of a and f of b on that interval. Now, I'm trying to, have I drawn a picture here? We'll draw some pictures down below is what it looks like. Okay, so again, I mentioned this word continuous earlier. Here's that word continuous. If it's continuous from A to B, and realize A and B are x values, right? F of A cannot, and F of A does not equal F of B. Realize that F of A and F of B represent y values, okay? Then F of x takes on every value between F of A and F of B on that interval. Here's A, here's B. Now, f of A cannot equals f of B means the point at f of A cannot be the same at the point as f of B. Does that make sense there? It's like f of A is the y value when A is plugged in. F of B.
Oh, so the y values can't be the same.
Right. Okay, so they're saying if this function is continuous on this interval and the y values are not the same, and we're just saying that because if the y values are the same, this could be a straight line, then the function takes on every value between f of a and f of b. Taking on every value means it's going to take on every y value between this. Okay, in other words, you can't just, there's not going to be something where it could skip and there's a gap. It's going to, every value is going to exist corresponding to an x value. Every y value is going to exist corresponding to an x value because it's a continuous function.
Not down there though in that little area, like under A.
No, because it says between f of a and f of b. So between f of a and f of b is going to be from here to here.
Okay.
Okay, it doesn't mean anything about above or below those y values. Yes,
So the f of a and the f of b, those are both y, and then a and b are both x.
correct. Okay. Okay. Another approach, said in a different fashion. If we know a y value, say y equals k, that resides between the two endpoints, f of a and f of b, then we are guaranteed at least one x value, x equals c, between the endpoints that generates the y value such that f of c equals k.
That literally
Okay.
doesn't help at all.
I know. Okay. Now, first of all, notice it said guaranteed, right? If we know an a value, a y value, say y equals k. Let me throw, I should have made this graph a little bit bigger, but that's all right. So, we're going to say k, that resides between f of a and f of b. So that means k, is that between f of a and f of b? Okay, so I'm trying to break this down. If we know a y value, say y equals k, that resides between the endpoints f of a and f of b, then we are guaranteed at least one x value, which they're calling c, between endpoints. So in other words, if we follow this over, where is this on my graph? It's right there, yes? They're saying that c, which is the x value that gives me k, is going to be between a and b, is what that's saying. If k over here is between these y values, then its x value has to be between a and b. That's what it's saying. Okay? It's fancy speak for it. So if he's like, whatever you say, I'm just going with it. So, I mean, I guess it's the idea that the ordered pair, c comma k, lives on the graph. I mean, that's what we're saying here. C comma k is a point on the graph. Okay. Now, we're going to do some graphical representation of our IVT. And let's see. I may have just done this actually. I think what I just did here, I should have just waited because we're going to get a bigger version of the graph now. That's all right. Okay. Let's see. It just says graphical. Yeah, we don't really have directions as to what to put in there, do we? Just graphical representation. The boxes down the bottom, a continuous function on interval, cannot skip values. Important outcome of IVT is that it can be helpful in finding zeros of a continuous function on interval. So I'll show that one there. Okay, so this graph is essentially here that here is your point A, here's your point B. Okay, and then if we draw some random graph, I'm going to make it a little different this time. That's my random graph that goes from A to B, yes? Looks like what?
How hard?
Okay, interesting. So right here, here's my A value, yes? Oh, did I not line that up very well? Well, we're going to pretend it's lined up.
Oh, mine's not like that.
Okay, there's my A value. Realize that where's f of A? F of A is the y value next to A, correct? And we have a B value here, yes? So we have a value B. And what is the y value over here? F of B.
Jeez.
Oh my
Hot
goodness.
Okay,
There's a lot going on there. All right.
now, the idea here is that if we pick some value, and I didn't give myself a bunch of room here, did I? But that's all right. If we pick some value here that is between f of a and f of b, so I'm going to pick this value here. It's between f of a and f of b, yes? And this is what we were calling k. That k value corresponds to what was the x value called? C. So that k value could also be known as f of c. But the idea is that if this k value is between f of a and f of b, then the c value will be between a and b. Okay? That's what your intermediate value theorem says. Now, a couple of things. Let's see. This point right here is the ordered pair C comma K. Okay. They referred to this line at one point as y equals K. So it could be referred to as y equals K as well. And about the only other thing I can include here is that this C value is between A and B, right? So we can write that as A is less than C is less than B. And at the same breath, we can say that f of A, actually, mine is just the opposite, isn't it? Yeah, it's not, because A is less than C is less than B, but C is between them, yes? Technically, my f of B is less than my f of C is less than f of A. Okay, but here's the idea. The specification here is that f of C is in between them. I forgot that. And the reason that switches is because I did draw a decreasing function here. That was part of the key there, is I did draw a decreasing function.
Shouldn't that one be A, the one at the end?
Yep. I shouldn't be using f of b twice, is what you're saying?
Yes.
Valid, I'll take it. Okay, and some of this happened. I did draw a decreasing function here. Okay. Now.
I didn't even draw a function.
Huh?
I said I didn't even draw a function. I
That
messed up. I was trying to draw it and I did my thin curve, so I have 2 points on A. It doesn't pass the vertical line test.
That's a problem.
Why did you do that?
Oh, and I guess the other thing I didn't label is that what is my function? That is this red curve, isn't it? F of x. I was trying to look at and see all the things I've labeled in my notes. So. Okay.
Pencil is fine.
Let me draw a different graph now. And this is going to kind of demonstrate the idea that this theorem is helpful in stating the existence of zeros. Okay? And that's the idea that I'm going to have an increasing one here. Okay, I'm going to start below A. And we're going to end above B. Okay? So the idea here is this is A, yes? This is B. Where's f of A? F of A is down here because it's a y value for my point at A. Where's f of B? F of B is up here because it's a y value for my x value of B. And this time, I'm going to put my C as right here on the graph. And it's on the x-axis. Because what I'm trying to show here, I can call this C comma 0, yes, is that if f of A is below 0, if one of them is below 0, f of B is above 0, then somewhere in between there is a 0. Okay? And so at this point, let's see. F of A is less than 0. F of B is greater than 0. So if f of A is less than 0 is less than f of B, then we have this 0 that must exist that we can call point C. Okay, and again, this is my function. So important outcome of IVT is that it can be helpful in finding zeros. So of a continuous function on an interval, as long as one of my y values is negative and one of the other y value is positive. Okay?
I think these are the best looking graphs I've ever made.
Honestly,
They're so good right now.
We can find Japanese things.
Okay. This is a rough place to stop because now we're going to come back on Monday.
And none of us are gonna have any idea.
Does the intermediate value theorem apply in the specified intervals for the piecewise function shown below? Be sure to explain completely.
I think yes.
Isn't it no? Because they're both piecewise.
On the specified intervals.
Oh.
2 and -2 and
In other words, looking at the whole graph, yeah, if we're looking at this whole graph, IVT doesn't matter because it has to be on a continuous function. But is there a value of x on the interval -2 to 5? So where's -2 to 5?
no, it's still no.
Yeah, it's not.
Yeah, it is.
Yes.
Well, I said
It's
yeah,
the
but you guys
line.
changed mine, so I was like, well,
What do you mean?
it's -2.
It's interval, so it's x and x.
Yeah.
-2.
I don't know.
Okay, wait a
Look at
minute.
me. Don't look at me like
Okay. There's two different questions here. Is there a value on the interval from -2 to 5
Oh.
Yeah.
where f of c equals 1?
Yes.
Yes.
Yes, and that is
3.5.
sure.
You are not looking at that question.
I was not looking
Yeah,
at that.
My brain was not thinking that question. Okay, that's where I was just reading more into it.
We were thinking.
So, yes, we can say C exists on -2 to 5. That is true, right? We're approximating C is 3.5. That doesn't matter. The next question, though, says, does IVT guarantee that C value?
No,
No, because
it's not continuous.
it's not continuous. So by looking at the graph, we can tell if there's a C value that matches that. But by using the IVT, it does not exist. So I have no, IVT does not guarantee a value of C on the interval -2 to 5 because it's not continuous. Okay? So you can always finish writing this down Monday if you need to. Does not guarantee a C value on -2 to 5, whoops, because, do we have a name for this? F of x is not continuous. Okay, so yes, it does happen to exist, but it was never, it's not guaranteed by that IVT because continuity is a requirement.
Yeah, that's not.
And I was reading it on A, does IVT guarantee it? And my answer key says yes, and I'm like,
No.
but it's not continuous. Then I realized, oh, that's question B. So
Like, I know I'm not-
don't do what I did. You've got to actually read, right? Okay, we will talk Monday more.